In this video, we are going to discuss how to find the percentage of composition of various elements in a compound, followed by from the percentage of composition how to find out empirical formula and molecular formula. First, let me discuss one question which is based on calculation of percentage of composition. Okay, so this is a question: find the percentage of composition of elements in magnesium carbonate. Okay, first what we have to do is we have to find out molar mass of magnesium carbonate. For this, we have to add atomic masses of all the elements together. In magnesium carbonate, we have magnesium, carbon, and oxygen. So magnesium atomic mass is about 24, carbon 12, oxygen is about 16. Now, so let us add these together. Magnesium one number, so 1 into 24, plus carbon also one number, 1 into 12, plus oxygen 3 number, 3 into 16, 48. So that we get a summation about 84. So that the molar mass of magnesium carbonate is 84 gram per mole. Correct. Now, in 84 gram of magnesium carbonate, in 84 gram of magnesium carbonate, MgCO3, we have 24 gram of magnesium. In 84 gram of magnesium carbonate, the mass of magnesium is about 24 gram, and mass of carbon is about 12 gram, and the mass of oxygen is about 48 gram, isn't it? Right. Now, let us find the percentage of composition of elements in this compound, isn't it? Right. First one, the percentage of composition of magnesium or percentage of magnesium. In 84 gram of magnesium carbonate, the mass of magnesium is about 24 gram, isn't it? Then what for 100 gram? If we calculate for 100 gram, then it is nothing but the percentage of magnesium, isn't it? Right. So that you are getting about 28.57% of magnesium present in magnesium carbonate. That is, in magnesium carbonate, the mass of magnesium itself about 28.57%. Okay. Similarly, 84 gram of magnesium carbonate has 12 gram of carbon. Then what for 100 gram of magnesium carbonate? So you are getting about 14.29. So that the percentage of carbon in magnesium carbonate is about 14.29, which means in the total mass, carbon mass itself about 14.29. Okay, right. Then the next one is percentage of oxygen. Whereas in magnesium carbonate, the mass of oxygen itself is about 48 gram, isn't it? Therefore, 84 gram of magnesium carbonate is containing 48 gram of oxygen. Then what for 100 gram? So into 100. So that you are getting about 57.14%. Okay, right. So that is how to calculate percentage of composition of various elements present in a compound. Okay, that is percentage. That is for 100 gram. In 100 gram compound, how much of each element is present? How much percentage of each element is present? That is what we call percentage of the element or percentage of composition of elements, isn't it? Right. So after finding out percentage of different elements in a compound, when you add them together, it is supposed to come about 100%. Okay. So now, so let me add these three values. So I am getting about 100%. So then it means that calculation is correct. Suppose after finding out percentage of every element, if we add them together, if it is not about 100%, then it means that there is some error. You can easily find it out. Okay, right. So then the next one, empirical formula and molecular formula. First, let us see some differences between empirical and molecular formula. Empirical formula is simplest formula of a compound. Empirical formula is a simplest formula of a compound. Okay, right. Then molecular formula, it is the actual formula. Empirical formula is the simplest formula, whereas molecular formula is a actual formula. Okay, right. Right. So next one, empirical formula is giving relative number of atoms. So empirical formula gives the ratio of the atoms, ratio between the atoms which are present in a compound. It is giving a simple ratio between the atoms which are in a compound, relative number of atoms, or is it relative number of atoms, whereas molecular formula gives actual number of atoms. So from the molecular formula you can say exactly how many number of atoms, particular atom we have, isn't it? But whereas empirical formula, it gives only a ratio, okay, between the atoms. Right, I have given some example for that. For benzene, the empirical formula is about CH, which means in benzene, the ratio of carbon and hydrogen is equal. Correct. But molecular formula of benzene is C6H6. So that this is the exact formula of benzene, which means that in benzene there are 6 carbon and 6 hydrogen. So which means it is giving actual number of atom present in the compound, but this is giving only a relative number. Carbon hydrogen ratio is equal. Okay, 1:1 ratio. But benzene molecular formula exactly shows that benzene has 6 carbon atoms and 6 hydrogen atoms. Okay, one more example, glucose. Glucose empirical formula CH2O, which means that in glucose, the carbon, hydrogen, oxygen ratio is about 1:2:1 minute. In glucose, the carbon, hydrogen, oxygen ratio. Glucose, I write the empirical formula again. Glucose empirical formula CH2O, isn't it? So this is merely giving the ratio between the atoms. So carbon, hydrogen and oxygen are in a ratio 1:2:1. Okay, that's what it gives a relative number of atoms. But look at the molecular formula of glucose. It is about C6H12O6, isn't it? Which means it exactly shows that in glucose there are 6 carbon atoms, 12 hydrogen atoms and 6 oxygen atoms. So molecular formula is giving exact number of atoms present in a compound. Okay, so these are some basic differences between empirical and molecular formula. Okay, now we are going to see how to find out empirical formula followed by molecular formula of a compound from the percentage of composition, of the compound. Okay, right. So let us see example number 1. Let's have this as example number 1. Okay, right. An organic compound has carbon 40%, hydrogen 66%, oxygen 53.4%, as well as it has vapor density about 45. Now the question is find empirical and molecular formula. Okay, so once after finding empirical formula, then only we can find out molecular formula. Okay, even though they ask find molecular formula, first we are supposed to find out empirical formula, then only we can move to molecular formula. Okay, right. Now this can be solved by drawing this tabular column format. Element, percentage, relative number of moles, simple ratio moles, simplest whole number ratio. Okay, right. So what we are going to do is, first we are going to fill up the elements. So that organic compound is having the 3 different elements: carbon, hydrogen, another one oxygen. Okay, I filled in the first column. Then the respective percentage. Okay, carbon about 40%, hydrogen 6.6%, oxygen 53.4%. Okay, so then third column you have to find out relative number of moles. For that, the percentage of every element has to be divided by its own atomic mass. Okay, 40 divided by atomic mass of carbon 12, 6.6 divided by atomic mass of hydrogen is 1. Oxygen percentage 53.4 divided by its atomic mass 16. So now we are getting this one, isn't it? 3.3, 6.6, 3.3. This is nothing but relative number of moles, isn't it? Now look at these 3 values. 3.3, 6.6 and 3.3. Which is the smallest one among this? It's nothing but 3.3, isn't it? Up now all these 3 numbers, are supposed to be divided by smallest number among them. The smallest number among these 3 is 3.3. So I am going to divide these 3 numbers by 3.3. Okay, so 3.3 divided by 3.3. The next 6.6 divided by 3.3. Next one 3.3 by, it's okay. I am getting 1 for the first case, 2 for the second, 1 for the third one. I make it as a whole number. Probably here in the last before column, you may get a number in a decimal. Okay. For example, if you are getting a number 1.2, so that you can make it as 1. nearest whole number. You can make it as nearest whole number. 0.5 below na previous whole number, 0.5 above na next whole number. Suppose if it is 1.2 na, you are making it as 1 previous whole number, isn't it? Suppose if you are getting 1.9, next whole number, you can make it as 2. Okay, right. So this is a conversion, whole number conversion, what you are supposed to do. Okay, just for example I gave this. Okay, right. Okay, right. Now last column, you are getting the simplest whole number ratios, isn't it? 1, 2 and 1. 1 for carbon, 2 for hydrogen, 1 for oxygen. Now we are going to write empirical formula. First write the elements symbol CHO. Then that simplest whole number ratio can be written as a subscript C1 H2 O1. So is no need to write the number 1, so that you can write it as CH2O. Okay, so this is the exact empirical formula of the compound which is having the above percentage of composition. Carbon 40%, hydrogen 6.6% and oxygen 53.4%. Okay, right. From this you have to find out molecular formula also, isn't it? Molecular formula, this is a formula to find molecular formula. Molecular formula is equal to empirical formula into N. Empirical formula into N, small n. That small n is nothing but molar mass of the compound divided by empirical formula mass. Sometimes in the question itself they used to give molar mass, that you can substitute in the numerator. If not, they used to give vapor density. You know the relation between molar mass and vapor density. 2 into vapor density is nothing but molar mass, isn't it? Whereas in the question it is given that this compound is having vapor density about 45. So when you multiply that by 2, you are getting molar mass. It is about 90, isn't it? Gram per mole. Similarly, you have to find out empirical formula mass, which is for the denominator, isn't it? It's nothing but adding atomic masses of the atoms in empirical formula. What is the empirical formula? Empirical formula CH2O, isn't it? Carbon 1 number, hydrogen 2 number, oxygen 1 number, isn't it? This is the empirical formula. But now just you have to add atomic mass of these atoms together. Carbon number 1 into atomic mass 12, hydrogen number 2 into atomic mass 1, oxygen number 1 into atomic mass 16. So that you are getting about 30. So molecular mass is 90, molar mass is 90, empirical formula mass is 30. So that N value is nothing but molar mass 90 divided by empirical formula mass 30. So you are getting 3. But now you are getting the N value, isn't it? So that we can go for molecular formula equal to empirical formula into N times. So this is the empirical formula I have written into N value is about 3. So that when you multiply by 3, you are getting C3H6O3. That is the molecular formula of the compound. Okay, right. So this is how to do the empirical and molecular formula calculation using the percentage of composition of different elements. Okay, so I give one more example for that. An organic compound has carbon 32%, hydrogen 4%, oxygen 64%. So find out empirical formula. This problem we are going to find only empirical formula. Okay, so as usual I have written the tabular column. Element carbon, hydrogen, oxygen, their percentages 32%, 4%, 64%. To find relative number of moles, I divide the percentages by the respective atomic masses. Okay, 32 by 12, 12 carbon atomic mass, 4 by 1 atomic mass of hydrogen, 16 atomic mass of oxygen. Okay, so I am getting 2.66 for first one, 4 and 4 for second and third. Now which is smallest number among these 2.66? So divide all these three numbers by 2.66. So next column, 2.66 divided by 2.66. I am getting 1. Then 4 divided by 2.66, 1.5. The last one also you are getting 1.5. Now you can see that in the previous example I said if you are getting simple ratio moles, if you are getting simple ratio moles 0.5 and above, I said 2.8. Now you can make it as a next whole number 3.0. If you are getting 2.2, less than 0.5, this is greater than 0.5, this is less than 0.5. Greater than 0.5 na next whole number, less than 0.5 na previous whole number 2.0, isn't it? So that by considering 0.5 above and 0.5 below, either next whole number or previous whole number, isn't it? But here you are getting exactly 0.5. See, exactly 0.5, isn't it? Then whether to make it as next whole number or previous one. So here what we do is we multiply by a common number, smallest common number 2, so that you are getting 2 here, 3, and for oxygen 3. Okay, carbon 2, hydrogen 3, oxygen 3. Therefore empirical formula C2H3O3. Okay, so this is a different problem in which you get simple ratio moles exactly 0.5. Okay, so in such a case multiply it by 2 and make it as a whole number. Okay, and get the empirical formula, right? I hope you understood how to find out the percentage of composition as well as molecular formula from percentage of composition. Okay, right? Thank you.